Hey guys, I'm starting to check out the RCA 630 TS I picked up recently. In particular, I want to check that all the critical components on the chassis are good. That would be the power transformer, focus coil, ion trap electromagnets, yoke, flyback. If any of them are bad, I will have to start the hunt to find replacements. Luckily, that might not be as bad as you might think, because although these sets aren't really common, they're also not really rare. Not only because they made quite a few of these, but RCA also licensed out this chassis and there were quite a few clones, so all told there were a few 100,000 of these made easily. But let's be positive and hope everything here is still good. First thing I want to check is what's inside here. That contains some power resistors that are kind of oddball values, and if they're bad, I'll have to get a little creative to find the replacements, or to cobble together replacements, because I'm not going to find the exact value. Unlike some other sets that use dual secondaries or other creative solutions to produce multiple voltages that the TV set needs, what RCA did is just use some heavy-duty power resistors and a voltage divider network here. There we go. So these guys in here, and those things get really, really hot, so they put them inside this metal container on the back of the chassis. And you can actually, if you look close, this is the paint on this is actually blistered from the heat. Well, my fingers crossed, but I've seen numerous restoration threads on this set, and quite often one or more of these are bad. This will be a first for me. I've never actually opened up one of these boxes or checked out these resistors. I've only seen pictures online. Or not. Alright, I just kind of assumed that by taking those 4 screws off that this top would just kind of fall right out. But boy, I don't know if that's paint fused on there or... Okay, there we go. Boy, that is just stuck on there. Really, really tight. Oh, yeah. Well, it looks like the ones I've seen online. Can't tell if it's good or bad at first glance, though. So we've got one huge power resistor up here. Although it's got multiple taps, it's actually 2 independent power resistors. It's not one big resistor that has taps on it. And then this guy down here, this is a tapped one. It's what they call a canned ohm resistor sometime. I guess that's because the resistor is sort of inside a metal can that's bolted to a metal plate, typically for heat dissipation. Alright, well, grab an ohm meter and see what we get. Alright, so section. That does not look good. Should not be that high of a value. So make sure you have really good contact. These terminals are kind of corroded. Try this side. That looks really bad too. These values should be under 5K. Uh, 67. No, that's not right. 230 ohms and 1,360 ohms, and I'm getting nothing even remotely like that. The one below that. It's about 5K. That could be alright. I should really unsolder some of these wires to make sure. There is one section at 6750, and with other stuff in parallel with it, maybe 5K is alright. This looks promising too. 15 ohms. And one final section. About 100 ohms. Okay, it should be 6750, 12, and 93. And I'm in the ballpark on that one, so I think that one could very well be good, but boy, not this one. Alright, so next up, I think I'll check the resistance on this stuff. Focus coil and yoke. And I'll do this guy too. The ion trap electromagnet. All the other sets I've ever worked on use permanent magnets for this, but in this set I used an electromagnet. But before I could do any of that, I want to check out what's inside this high voltage cage. I don't think I have yet. No screws holding the high voltage cage on. Well, I don't see anything missing. Cap has gone off of the horizontal output tube though. So I don't know what happened there, but there's no way this set would have worked as is. Gotta need that cap on there. Looks a little dodgy too. What I was referring to as dodgy is this. That's the high voltage filter cap, and it's not really mounted. Normally these are screwed down quite securely, and the leads are dressed very nice because you got a lot of voltage on there, so that might be a replacement. Now luckily I have the luxury of having another 630 TS, so I can compare it to that, and the same goes for everything else in this set for that matter. I think that's the original Flyback. And just visually it looks alright. I mean, it's not, I don't see anything melted or any obvious signs of arcing. And the insulating coating looks to be in pretty good shape. Hopefully that power resistor is okay. While I'm testing this focus coil, I also want to attach it properly. These aren't the original screws, and there's no nuts holding them in place, so it's really just flopping around. Not the way it's supposed to be, for sure. Obviously the yoke's very loose too. Same deal. I'm sure these aren't the original screws. They wouldn't have used Phillips screws like that originally. I decided to pop the top on my other 630 TS for a little comparison. Right away I can see what the mounting hardware should look like on the other one. Basically 3 wing nuts on the yoke, 3 wing nuts on the focus coil. So I can hunt around for some replacements. And here's the inside the high voltage cage. Looks quite similar, including the high voltage cap. I thought it looked a little odd in the other set, but no, this one pretty much looks the same, and this one's a little wobbly too, so I guess that's just how they did it back then. Unfortunately, I can't get inside this so easily because I can't get at the 2 nuts on this side. Well, actually, there's only one. Or no, the other one's there. It's just driven in so deep. I couldn't quite see it. I can't get those out while it's inside the cabinet. I need to get a wrench in here, and I can't really get one in from here. Well, maybe I can. I'll look around and see if I have a little box wrench, or open end wrench rather, and maybe I can slide it in there. Otherwise, I need to get underneath this cabinet and remove the bolts. Let's see, I wonder. I think this table is actually, yeah, it is. Well, I don't know if that was intentional or not when they designed this stand, but there's no shelf underneath the set, so you can actually access the set pretty easily while it's on the stand, including the chassis bolts. I can see 3 out of the 4 bolts are there, so if I just reach underneath the stand and take those 3 bolts out, I can slide the chassis out and then look inside here. The reason I want to is I've been searching around online for some replacements, and if I'm going to order some up, I might as well get them for both sets if I need them. Well, I'm just not lucky today. These are all bad. Every section, both resistors, all open. So I now have to hunt for some replacements for these as well as these guys. This one's riveted on there, which is kind of unfortunate, but I did read about one trick you can do with these Candome ones is you can leave them mounted and attach the new resistors across these lugs. But you want to make sure that the windings inside are definitely open, because you don't want to ever have this, through some vibrations or whatnot, reestablish conductivity, so it'll be in parallel with the other resistor, which would be much too low, which could cause problems. I printed out this little checklist so you guys can follow along with what I'm going to be doing in this video. So we're still at the power resistor stage. This guy seems to be okay. This one is bad, both sides, and that one seems to be okay. So I went hunting around through my stashed power resistors I've accumulated over the years, and didn't find quite what I was looking for, but I found some that look like what I'm looking for. In other words, it's the right packaging style. So this is what I meant by a variable tapped power resistor. So they take one of these fixed value, like this is a 10 ohm, scrape away the vitreous enamel coating and put a slider on there so you can adjust it to whatever value you might need. So this should be 1360. They don't make those, but they do make 1500 with the slider. If I slide it over, I can get my 1360. These are 25 watts. The originals were 17 and 10, so it should be no problem. Now the other ones should be 230, which they also don't make anymore. They make 200s and 250s. So I was thinking I could either go with the 250 fixed, even though it's a bit high, but it's within 10%, or I could get a 250 adjustable. Still kind of on the fence about that. Reason being is that the adjustable cost about twice as much as the fixed, and these are not that cheap. Adjustables about $10. I found a range about $8 to $11 from various vendors, and the fixed are around $4. these are carried by quite a few places: Mauser, DigiKey, Allied Electronics, and I'm sure others. So at least it's nice that Ohmite still makes these, and they will mount precisely like the old one did. Put two of these side by side, and they will fit in perfectly. Yeah, you can get cheaper power resistors like the cement type, but I want to go with these because I won't have to rig up any kind of mounting. They'll just mount right in there, hook the wires right up to them, no problem. While I was digging around, I also found this, which came in a box along with this set. This is identical to the one that's down in there. One exception: this one's bad. Its main section is completely open. This is probably the original that had been replaced sometime in the past, and they hung on to it for whatever reason. At least I got some of the mounting hardware, which they also still make. You can get this stuff at Allied Electronics, is what I'm going to place in my order. And they sell the mounting screw, these end caps, the mica insulating washers, all this stuff. All still made. Alright, so there's one less power resistor I want to check. It's a 5K 5 watt. I haven't found it on the top, so I suspect it's underneath somewhere. Eventually I tracked it down to this guy, which looks like an old 30s type Dogbone resistor. I was able to verify it because one end of it's going to pin 3 on the 6K6 horizontal oscillator tube, just what they show in the schematic. So this is supposed to be 5K. And I'll tell you, even if it measures 5K, I'm going to replace it anyways, just because it looks pretty decrepit, and I'm not quite sure it's the original, because I don't think they were still using resistors that look like that in 46. So what do we have? Well, that's pretty far off. So far off, I think I might have to lift up one end of this. So it's measuring almost exactly half of what it should be. It's more common for resistors to go up in age, or for wire wound resistors. Basically, they're good or they're bad. I mean, if they're not burned open, they're always measured pretty darn close to what they're supposed to, because the wire, they're made out of resistance wire, and that just doesn't age, whereas carbon type resistors do. And I imagine this is probably a wire wound resistor, so let's see. Okay, it's out of the circuit now. Let's see what I measure this time. Huh, 2.3K. Well, it's got to go. Should be 5K. 5K 5 watt, that's easy enough to find. That I probably do have on hand, as well as the other various power resistors. There's a few 1 watt and 2 watt resistors throughout the set. I already double checked those. I've already got on hand. So the only thing I need to order for this set is just a couple of these guys in the right value, and I'm all set. But while I'm at it, since I checked the other set, I'm going to order up 2 of each of these for that set, and I also will order up the other power resistors that go below these inside that box, because those are bad as well. Alright, now let's move on to the ion trap electromagnet. Okay, the ion trap electromagnet connects down in here parallel to this 56 ohm resistor. And there are 2 sections to it. Should be 33 ohms and 3 ohms. So if I leave it in the circuit, it's about 36 in parallel with 56. We're going to get 20 something ohms if it's still good. So let's see. Alright, 22.4. Alright. I'm going to call that good. Sure, it could be open and the 56 ohm resistor might have drifted down to 22.4, but that seems extremely unlikely, so I'm just going to assume it's okay. So next up, focus coil, which is right here. And that's a parallel with an 1800 ohm. And one end of that goes to that same 56 ohm resistor. So we got one side of it, and I'm just going to track down the other side. And I see an 1800 ohm resistor here. Other leg of it's going to this big old pot here, which has got to be the focus control. Yep. So if we go across that 1800 ohm resistor, and the focus coil is 247 ohms, so it should be like 200 ohms or thereabouts if it's good. Alright, cool. Now comes the yoke. That'll take a little more work to track down. I figured the easiest way to check the vertical yoke windings was to disconnect one of the leads going to the vertical centering control. It's kind of an odd control in that it doesn't just have the usual center wiper and then two outside leads. There's also a fixed tap. And that's where I ended up disconnecting. So that's this guy right here. So with that out of the circuit, if I put my ohm meter to that wire and to the other one, go around here, pick up about 7 ohms on the vertical output transformer, then 68 ohms total through there. So we should get around 78 ohms. This is the tap on the vertical centering control, and there's the wire I just disconnected. And the other connection I'll simply make to the center tap, which is down in here. Or not the center tap, rather, I mean the wiper on the control. Down in there. And we get 65 ohms. I call that close enough. Obviously neither one of the coils is open. I'm checking the horizontal yoke winding now, which turns out to be pretty easy. If you put one end of your ohm meter on the wiper of the horizontal centering control and the other on pin 4 or 6 of the 5V4 tube, you should get around 14 ohms. That's the horizontal centering control. Got a clip going to the wiper down there, and the other end is going to pin 4 on the 5V4, and I've got pretty darn close to 14 ohms. I decided for the RCA I'd fire up the ICO 944 and see what it had to say. First I'm checking for continuity, which is the bottom range, and you want to be into the green. We're well over on the left, that's good. That means you don't have an open coil. But when I check for shorts, which is the topmost scale, we're in the bad. We're over here. We want to be over here somewhere. I've hooked the 944 up to my other RCA 630TS, which also had a very grungy looking ancient 1B3, which may also be the original. So, continuity all the way over at the left, just like the other set. And when I do shorts, it's just about in exactly the same bad position. Well, I consulted the manual for the 944, and this is exactly what they recommend you do when you do get a reading that's kind of in between the good and bad, to almost in the no man's land, is compare it to another one. Ideally one that you know is good, and if you get about the same readings on both, it's a pretty good indication that it is good, and for whatever reason the meter just can't quite handle this type of flyback. So I think we're in the good on both of these, since we got the same reading on both. The odds of them both being bad in the same way, I think, is much less likely than them both being good. So that just leaves one thing to test: power transformer. Now I'm going to test that by popping these two big old 5U4 rectifiers out, plugging this side in and turning it on. If the transformer is good, 1, This tube should light up, the tubes that are left in the set. And two, I can stick a meter down in here, and let's see, do they tell us what voltage we should get? No, they don't, but they do tell us the DC voltage, I believe, somewheres. Yeah, so between the two, it's like 375 if you go from negative 100 to plus 375, and I can kind of guesstimate what the secondary voltages should be across there, and we should have 5 volts AC going to the rectifier tube, so probably something like 400 volts on either side of that center tap. And yeah, the rest, if all the tubes light up, they should be good. Alright, now for the moment you've all been waiting for, I'm going to turn it on. But before I do, I made sure to pull out the two 5U4 rectifiers, which means there will be no DC voltage going to the set, just filament juice. I've got my meter hooked up to the center tap. I was able to find a good place to hook that up by tracing this down, and I noticed that it goes to one side of the focus coil. And I already figured out where that hooks up. So I tied in right here to one side of this 1800 ohm resistor. The other side I've got going to one of the rectifier tubes, pin 4. I'll check that side, then I'll check pin 6 for the other side of the secondary. And as for the other filament windings, well, if I see tubes glow, then they must be good. That is except for the 5U4 filament windings, because they are dedicated just for those two tubes, which I've pulled out, so those two I can also check by putting my AC voltmeter between pins 2 and 8. Now, since I've never turned this set on before, I'm doing a couple things. One, I'm going through a light bulb, just in case it's a dead short, and I'm also going through my variac, not because I want to control the amount of voltage, just because it's got a fuse in it. The set does not. Alright, so let's turn this on, and then turn the set on. Oh, that's bright. But it's dimming down. And we've got AC. It's like around 300 volts. So it'll be about 700 plus. Or let's say, yeah, 630 or so. I remember that's with no load, with the set really powered up to present more of a load. And I can see the tubes are lighting up, which is fantastic. So I think we've got a pretty healthy power transformer. But just to be extra sure, better check the other side of that rectifier, which I'm not going to do with the set turned on, because I'm trying to hold the camera while I'm doing it. Alright, there's the other side. Set back on. Yep. Got about the same AC on the other side of that, and the one final thing I want to check are the filament windings to the rectifiers, which should be, it's 1 and 8. There. Alright. Here. Right. Alright, that's about 5 volts. Alright, cool. Well, that completes the checklist, and other than the power resistors, which should arrive tomorrow, everything else seems to be alright. Here's another look at all those tubes glowing. And if I haven't mentioned it before, this power transformer is massive. All those tubes suck up a whole lot of juice. Look at the size of that thing. That's why the set's so heavy.